Linear factorization theorem. If a function is a polynomial of degree n, where n is greater than 0, then an nth degree polynomial has n zeros, and an nth degree polynomial also has n linear factors. So what that means is whatever is the degree of your polynomial, that's going to tell you how many zeros you have and how many linear factors you're going to have. Let's use an example. We'll start with a trinomial that you may be familiar with. So first we want to know what is the degree of this polynomial, also called trinomial. Well, all you have to do is look at all of your terms, and when we talk about degree, we're talking about the exponent. So you look at all of your exponents, and whichever one has the highest number in terms of its exponent, that's the degree of your polynomial. So this exponent has a 2. This is an exponent of 1. We don't write it, but we know it's there. So 2 is greater, so that means that this is a second degree polynomial, which means that you're going to have 2 zeros and 2 linear factors. Now to write that in linear factored form, I'm going to go ahead and factor this trinomial. And this is what it factors into. And notice that I have 2 linear factors. Linear factors is when you put your x's back in as x plus something or x minus something. Now the zeros, all you have to do is solve for x. Set each parentheses equal to 0 and solve for x, and that will tell you your zeros. So the zeros here are 2 and 3, because when I solve for x, that is what each will equal. So I have 2 zeros and 2 linear factors. Let's do another example. So as we can see, out of all the degrees, the highest degree is a 3. This is a third degree polynomial, which means I'm going to have 3 zeros and 3 linear factors. So to write that in linear factored form, it's going to look like so. And as you can see, I have my 3 linear factors. All you have to do is simply solve for x to identify your zeros.